All right, guys, this is part 3 of that 2.5 video. So we're going to take a look at example 5, and it says find the following limits analytically and then verify with a graphing calculator. So for A, what we're going to look at is we want to find the limit as x approaches infinity of x over the square root of x squared plus 1. Now, you might be initially sitting here looking at this saying, okay, the degree on the bottom is 2, the degree on top is 1. But really we have the square root of x squared plus 1 in the denominator. And in this example, we're specifically looking at what happens as x goes to infinity. So basically, you're going to have infinity squared plus 1. Well, in that situation, infinity squared is going to dominate that value. That 1, in a way, becomes irrelevant. All right, so from a limit standpoint, as x becomes a very, very large number, okay, or quantity such as infinity, we can think of this expression as the limit as x approaches infinity of x over the absolute value of x, where in a way we're kind of ignoring the plus 1 and just evaluating the square root of x squared. And the square root of x squared is the absolute value of x. So in that situation, okay, you now have x over the absolute value of x, which are both x to the first power. So we can use the idea of horizontal asymptotes, okay, where you have a positive over a positive, same degree, we simply get 1 as the limit. All right, and we're going to take a look at these on a graphing calculator here in a minute as well. So if you were to take this idea, now when the limit is negative infinity, you know, x is x, we can think of the square root of x squared plus 1 as the absolute value of x. So now when you plug in those values to get closer and closer to negative infinity, your numerator is going to be a negative value. Your denominator is going to be that same value but positive. So when you have a negative number divided by the same positive number, you're going to get negative 1 as the limit. All right, so let's just take a quick look here of graphically what that looks like. So on our graphing calculator, we should be able to go, all right, and we want to have x divided by the square root of the quantity x squared plus 1. All right, so if you hit enter and you look at what's happening with this graph. Now I'm going to adjust my window a little bit. All right, specifically talking about our y values. And we're going to look at y values from -2 to 2. And I'm going to go ahead and expand our x values. I'm going to go from -1,000 to 1,000. You know, because we're looking at limits to infinity, we want to try to get an idea of what's happening. Okay. So if you look, all right, now it's not very clear exactly what's happening, but you know, let me kind of adjust that real quick. Hang on one second. Maybe I should have shown you guys the 10 to 10 first. So if we go from -10 to 10, and we look at what that's doing, you kind of look, this graph has somewhat of an S-shaped curve, right, where it's going up to the right and it's coming down to the left. All right, we narrowed our y values down from -2 to 2. So this height up here is at 1. Basically, you have a horizontal asymptote at 1 and a horizontal asymptote at -1. And as x is approaching infinity, the graph is approaching a height of 1. As x is approaching negative infinity, the graph is approaching a height of -1. All right, and I just, in the window before, I was just expanding that to go from -1,000 to 1,000, you know, and just to show you that the graph it never climbs above 1. All right, it gets to a point where it levels off at 1 and -1 as you go right and left. All right, so graphically that verifies this. I mean, the key thing is understanding that because we're doing a limit to infinity, this x squared is going to have, a dominant impact on this expression, and the 1 becomes basically irrelevant as x becomes very, very large. All right, so if we look at the other example, C here, we want to know the limit as x approaches negative infinity of the square root of the quantity 4x squared minus 8 over 3x. So again, we want to think about this as, the 4x squared is going to dominate. Well, the square root of 4x squared is 2x. So the absolute value of 2x over 3x. Now, as you plug in negative infinity, right, or numbers that get closer and closer to negative infinity, the x's basically cancel, all right? When you plug in the negative, you're going to have absolute value of a negative number on top, so it's positive. But you're going to have a negative number on the bottom. So a positive divided by a negative is a negative, so in this case, negative 2/3. And that's the limit as x approaches negative infinity. All right? And again, you could plug that into your graphing calculator to verify that is in fact true. Okay, a couple more examples, guys, and then we will be done with the 2.5 notes. All right, the next example talks about find the limit, if possible, of the limit as x approaches infinity of cosine of x. So now we're talking about the cosine curve. So if we just looked at one period of cosine real quick, and what its graph looks like, -1 here, +1 here. So cosine starts with a maximum of 1, then you've got a 0, then a minimum of -1, back to 0, back to a maximum. All right, so the graph of cosine for one period looks like that. But then that period, that period of cosine, it just repeats itself. Okay, so it's going to just be this wave that's going to continue to do this. Well, as x approaches infinity, it's just going to continue to bounce back and forth from -1 to +1. All right? So this has to do with that oscillating function, and when the function oscillates, the limit does not exist. So the limit as x approaches infinity of cosine of x does not exist. All right? With the reason being because it oscillates between -1 and 1. All right. Example 7 here. So as this is another one of those, just like 5 on the front, when you see limits of square roots like this, you want to think if you can simplify it, rewrite it in a simpler form. And in this case, because it's a limit to infinity, we can think of this as the limit as x approaches infinity of the 9x squared is going to dominate the expression underneath. So the square root of 9x squared is the absolute value of 3x, and then 3 minus 5x. This is going to be dominated by the -5x. All right, so at that point, what you would think about is, what am I plugging in, right? So if the limit's approaching positive infinity, you're going to get a positive value in the numerator, and you're going to get a negative value in the denominator. So a positive divided by a negative, and again, the x's are going to cancel out. So positive divided by negative is going to give us -3/5. All right, and now if we looked at the same example, we can use this, or the next example, we can use the same expression where the numerator is we can think of it as the absolute value of 3x, the denominator is -5x, but now we're talking about a limit to negative infinity. So when I plug in negative infinity or a negative number, I'm going to get a positive on the numerator and a positive on the denominator, because you've got a negative times a negative. So a positive divided by a positive will give us a limit that is positive 3/5. All right. And again, you can always plug these into your graphing calculator to verify those answers. All right, guys, that is it for the 2.5 notes. Make sure if you have questions, ask your teacher. Otherwise, you can rewatch the video if you need to see it again. All right, guys, have a great day. Bye.